Welcome, everyone. Hi from my side. Welcome to the webinar on Spring Framework 4.0. Actually, it's covering even the state of the immediately upcoming 4.0.1 release. So you get the very, very latest here. 4.0.1 is scheduled for release on Monday, so just in a few days here. And there's a note or two that are actually specific to 4.0.1, even in this very presentation here. But fundamentally, we're covering the Spring Framework 4 generation, which is, well, the fourth major generation of Spring to begin with. It's in particular the first time that we really raise the baseline here after the Spring Framework 3.0 release. We spent quite a bit of time with Spring Framework 3.0, the 3.0 line. We introduced Spring Framework 3.1 with very significant new features back then. And we kind of ended that line with the 3.2 generation, which is still actively maintained. Spring Framework 4 presents an opportunity for us to basically revisit the entire framework. And this is what this webinar is about, really. I'm going to explain a little bit about the motivation, a little bit about our kind of mission here. What are we focusing on? What are we driven by? And I'm also going to specifically explain a few things about upgrade implications. So this is as much about introducing Spring Framework 4.0, the framework itself, as it is also about introducing Spring Framework 4.0 releases to your deployment environments, to your development environments and your deployment environments. Since we really went the extra mile to make sure that it's a smooth upgrade from Spring Framework 3.2 in particular, definitely consider that upgrade. We'll revisit this towards the end of the webinar. First of all, let's just look where it's actually positioned in our portfolio these days. Spring Framework 4.0 is the foundation of many things that we do. In particular, it's the foundation for what we call the Spring I/O platform, which will see its first release in actually not far out at all from here. Spring Framework 4.0 is the foundation layer, has many pieces on top. The next generation of Grails running on top of Spring Framework 4.0. Our Spring Boot initiative being entirely Spring Framework 4.0 based in Spring Framework 4.0, really enabling the things that Boot can do. And our Spring XD initiative going into big data scenarios, data ingestion, a fresh new approach to think about those kinds of architectures. All of those things are Spring Framework 4.0 based, or will be Spring Framework 4.0 based in the very, very near future here. So we're going to focus on Spring Framework for the remainder of the presentation, but definitely check out a few of the other projects that we're doing here. Spring Boot in particular, I'm going to talk about it just a little bit, to refer to it a few more times. So this presentation is about the Spring Framework perspective itself, more traditionally framework oriented, but keep in mind there are fresh new ways to actually use Spring the framework and Spring in terms of middleware functionality with other projects in our portfolio. So let's start with a recap of the state of the art. The idea here is I'd just like you to go with me through a few slides indicating code examples, showing code examples that indicate a few important features in the Spring Framework 3 generation. It's basically the heart of the component model, of the annotation-based component model. What does it look like in the Spring Framework 3 generation? And let's start with a component here. That's just a regular Java class, annotated with few annotations, making it a first-class citizen in the Spring component model. And we actually see three kinds of annotations here. We have an add service annotation on top, which is a stereotype, which basically tells us something about the class. It formally tells us something about the class. It's basically a formal way of saying this is a specific kind of class. It's a service class. We have add auto-wired, which is a And good example for a dependency injection annotation. You could also use JSR330's add inject here, or you could use Spring's add value in similar places with expressions. Those are all dependency injection annotations. They basically identify a constructor here as the primary target of injection if no other indications are given. If there's no other metadata influencing this, the container will choose this one in a simple scenario. Add auto-wide can also be used on fields and methods, of course. The third category down there is add transactional, an example for a declarative service annotation. There would be, of course, others in other domains, add scheduled, for example, for cron triggers and so forth. They all allow you to tap into middleware services through the use of component level annotations. But that's runtime impact, right? There's always runtime impact. Spring as a component container can discover components in the class path through searching for stereotypes, for compliant stereotypes. So add service above can actually serve as kind of an identification mark in the class path for class path searches. Add auto-wired, of course, has runtime impact. It makes Spring choose this constructor or one of the annotated constructors when creating a new instance of that service class. Add transactional has obvious runtime impact, right? Container will begin a transaction before it invokes your method implementation, and it will commit it or roll it back at the very end. That's the runtime impact of those things. But let's take a step back. We look at a piece of source code here. And those annotations are as much about the readability of that source code as they are about runtime impact. So forget about the runtime impact for a moment. You see a Java class here. The add service annotation tells us something about the role of that class in actually a descriptive, nicely worded way. Add transactional tells us something about the method. The method is transactional. It basically formally defines characteristics of that method that are also important to the reader of that class. Even add auto-wired in terms of wording, this constructor is auto-wired if no other information is given. So those are really descriptive metadata elements in your source code. That's what annotations are initially. And from a design perspective, that's what they primarily should be. Runtime impact follows from there. So that's a component class, a typical component class. Many of the annotations in Spring are composable, as of Spring 3.1 and 3.2 in particular. Composable means you can build your own annotations and use Spring's standard annotations, the out-of-the-box annotations, as meta-annotations. This may be a little unusual initially, but fundamentally it's a completely normal thing to do. You build a new type in your code base. It's not an interface, it's not a class, it's an add interface, it's an annotation type. And in order to define that type, you add annotations on top of that type. So the my service annotation shown here is a custom annotation of yours, as an example. Basically combining the characteristics of a standard Spring add service, defaulting the scope to session, marking it as primary, which means if the type match is not unique, this one is preferably injected into other components, and a default transaction rule even. These rules basically are combined into one single add my service annotation. From that perspective, it's a kind of shortcutting model. Every time you say add my service, what you're actually saying is add service, add scope session, add primary, and the add transactional rule above. However, the shortcutting is kind of a really nice benefit. It's as much about the name as it is about the shortcutting. My service might not be the greatest name in the world, but the name is basically up to you. You're free to choose your own name. And I would definitely recommend using a good, meaningful, expressive name within your layout, within your application architecture. Maybe order service, account service, or a specific kind of service role has a meaning in your architecture. By all means, if you're building custom annotations, choose good names that actually correlate to basically terms in your architecture. Add my service, of course, here or any other such annotation can be used on any number of types. So to benefit from the shortcutting nature of these things, you can use them on hundreds of types if necessary, and they always express the combination of characteristics above. This is a stereotype annotation being composed. Many other kinds of annotations in Spring can be composed in the same way. You can build custom scope annotations, you can build custom transaction annotations, even custom bean definition annotations, or a custom injection annotations, right? The composition model here works basically for almost any kind of annotation in the Spring framework. An important part of our configuration model in the Spring 3 generation, that's a configuration class, right? Configuration classes. Configuration classes are fundamentally a collection of factory methods that in combination with specific annotations serve as definition points for Spring beans. So basically you can define any number of Spring beans through configuration classes. Instead of putting them into XML bean definitions by name and type and a few external properties being set, we're basically switching the focus and we're saying, all right, the heart of it all is the factory method that builds the instance. That's like this my book-admin service method here. The name of the factory method serves as the default bean name. The return type serves as the kind of initial bean type before we build an instance. The add-bean annotation basically marks it as producing a bean definition. You can also specify additional characteristics at that level. You can add a lazy annotation, a primary annotation, qualifiers, that sort of thing at this level. A configuration class can have any number of such add-bean methods. They can call each other with special semantics where the Spring's lifecycle management still very much applies even for calls within add-bean methods. There's a stereotype on top, add configuration, basically says we're within a special kind of class, we're within a configuration class. Spring stereotype model in action for this out-of-the-box configuration class model here. There can be any number of configuration classes in your system. You can have one with 100 add-bean methods or 100 configuration classes with one add-bean method each. It's up to you. So they are also a unit of combining a certain bean arrangement. So you can basically use them as a kind of structural element for structuring your configuration arrangement in a comprehensive form. Also in a form that just allows you to follow what you actually meant to configure. There's two further kinds of annotations shown here, and just quickly a note on them. There's an add profile on top. Add profile is a simple kind of condition, of a bean definition condition that basically says the beans defined by this configuration class are only actually being registered with the container if the profile called standalone is marked as active on startup. Then and only then. There can be any number of profiles. So you can have a whole arrangement, a whole matrix of profiles if you want to, combining different variants of setting up your system, your application through a combination of profiles. There can be profiles that refer to specific verticals in your architecture, or you can have profiles for specific runtime platforms or for specific target middleware that you're configured to interact with. So profiles are really a very flexible mechanism, but they are fundamentally pretty static. Profiles have a name. Those profile names may be set as active on startup. That's basically it. We're going to revisit this from a Spring Framework 4 perspective in a few moments. Another, just a quick focus. Within the Spring component model, type matches play an important role. You can refer to a specific bean by name if you want to have it injected. Traditionally, with external bean definition formats, that's what you would do. That's also what you would do with the add resource annotation in the annotation-based component model. However, with add autowired and add inject, you're basically indicating a type match. You're saying, I've got a constructor or a field or whatever here. The constructor has an argument, takes an account repository. It may have any number of arguments, but in this example, it's just one, an account repository. It basically requests a dependency of type account repository by type. The idea is that in 80% of the cases, there's only one match for the given type registered with the container to begin with. Keep in mind, type matches in Spring refer to the well-defined set of bean definitions currently managed in the container. So it's about actually registered bean definitions. It's not about arbitrary beans that hang around in your class path and happen to match the type. It's about registered component classes that are registered with the container. For example, the profile mechanism shown before can actually pre-select what's actually registered with the container. It can serve as a kind of filtering mechanism for some things not to go in some scenarios. However, in any given kind of arrangement, you've got a number of beans defined. Some injection points are shown above. This one wants an account repository. Some definition points, typically in a completely different corner of the system, some configuration classes probably. There's a bean defining, there's a factory method defining a bean of type account repository. Spring is basically about making that connection. Right? When the injection point says, I want an account repository, Spring looks at the set of beans, finds matches by type for account repository. If there's only one, all is good. If there are several matches, we have to rely on additional metadata. You have to help us, basically. And what we see here, the qualifiers, serve exactly that purpose. You would only use qualifiers if the type match is not unique. So account repository, let's assume there is more than one match, maybe a production match and a testing match. Both are registered with the container at the same time. Then you can add the add qualifier notation, in this case with a string qualifier production, to your injection point above. You can add the same qualifier to the definition point below, to the factory method. Spring would immediately, without any further setup, consume that additional information when connecting the pieces here. So it would say, okay, account repository it is. We have a qualifier production. There is an account repository match. It also has a qualifier production. So those obviously go together. Let's inject exactly that one. So that's qualifiers to be used when type matches are not unique. We're going to revisit this as well from a Spring 4 perspective. Last but not least, in this quick state-of-the-art tour, MVC controllers. And I'm not going to talk much about the MVC controllers themselves. I suppose most of you are familiar with them. Let's look at them from a design perspective. They have a stereotype above at controller. They have a number of methods, method-level mapping annotations. MVC controllers are basically an endpoint model. They define HTTP-based endpoints with incoming HTTP requests being mapped onto endpoint methods through the request mapping annotations here by path. We additionally use the parameter signature here. So the parameter signature may be pretty important for each such method. Our findbook method has a long ID, which in itself doesn't really mean much. Remember, source code readability. If you look at just a long ID, what is this, right? There are no magic rules attached to it quite so easily. We use parameter level annotations typically to indicate what kind of parameter this is. So in our case here, we say long ID, that's an add path variable. It's a parameter level annotation. If there are several parameters for a method, each of the parameters may have its own annotations, or typically a single annotation per parameter. In this case, we say it's a path variable. This parameter refers to, this method parameter here, refers to the path variable in the path above. There's an ID variable defined in the path mapping. That's what we refer to. There can be several of those path variables, so we rely on the parameter name to point to a specific variable by name. And we automatically convert it to a long because we can infer that from the signature. So this is about source code readability. The source code should basically say what it does in pretty obvious ways, even to people who are not so familiar with the intricate detail. And the runtime behavior is, of course, derived from the same annotations. Spring's dispatcher servlet does a good job at that. It basically introspects the request mapping annotations, all the parameter annotations, and just does the right thing according to a set of rules. One specific note here, the ID parameter. We already explored that its name is relevant. There may be several path variables. They match by name. However, in standard Java, there is no representation of the parameter name in the bytecode. Basically, for method parameters and constructor parameters, the name of those parameters sits in the source code in your Java files, but it's not preserved when we compile it down to bytecode. In the bytecode, it's just an index and a type. That's what parameters have. No name. In JDK 6 and 7, what we do on Spring 3 and also in Spring 4 when we run on JDK 6 and 7 is, if there's no further information given, we need to know that name. So if you don't explicitly say what the name of the path variable is, you can do that as path variable and an attribute ID. You can help us that way, but then you're repeating yourself. We don't want you to repeat yourself. So what we see here is actually preferred, but then we need to learn about the name at runtime. That works as long as you compile your classes with the -debug compiler flag. Then the compiler basically inserts a debug section a debug symbol section into your class file, which happens to contain the parameters for all methods and constructors that have a body. So not for abstract and interface methods, but for methods in implementation classes. That's all we need here. We basically read debug symbols. We use ASM, parse the class file, read the debug symbol section. We cache it, of course, and then we can infer the parameter name from there. That's the best we can do on JDK 6 and 7. We're going to revisit this as you may have guessed. All right. Spring Framework 4.0 is basically an attempt to raise the baseline, and we're going to just explain what this really means in a moment. But it's also fundamentally improving on the Spring Framework 3 component model and taking it to the next level, actually in many subtle details. From the component model perspective, a lot of it is about revisited runtime behavior. The component model is very much what you used to work with in Spring Framework 3 here. So if existing Spring Framework 3 applications and existing Spring Framework 3 know-how can just move along. And in Spring Framework 4, we are building on it, refining it, fine-tuning it. And we're upgrading it to a Java 8 level. All right, but for a start, let's define the baseline. What do we mean here? Fundamentally, Spring Framework 4 as a generation of the framework is defined to serve the needs of 2014 and beyond here. It's basically a very forward-looking perspective that we're applying here. We take application architectures as they are being used right now, as they are being developed right now, which are not necessarily your traditional application server-based architectures. It's about embedded web service, bootstrapping an application with an embedded web server. It's about talking to non-relational data stores or other kinds of non-traditional data stores. It's about lightweight messaging, far from the rather heavy enterprise integration style of messaging that's been so common. It's about WebSocket style communication architectures between clients and servers or different parts of a server system. And it's in general about asynchronous processing, basically about composing your application in a way that allows you to make the best possible use of the processing power that you have available at runtime. But if you have a multi-core machine, you better design your system to make some good use of those cores. And it's not always so easy. It's easier for web applications than for other kinds of applications, I suppose. But there are many kinds of applications many kinds of systems where this becomes a real challenge. The idea here is, from a programming model perspective, that we're not doing anything truly magic. We're not trying to take your code and to interpret it in a fancy way on a multi-core architecture. We allow you to define an application architecture of your choice. And the framework basically supports you in your challenge along your way of building a system for those kinds of scenarios. So typically, you're pretty explicit. You decide, you declare when you want to go asynchronous. You explicitly build messaging endpoints. Spring assists you to do that in a clean, convenient, and consistent way. We interpret the baseline term also as a dependency baseline. So as of Spring Framework 4.0, it's JDK 6+, Java SE 6+. Actually, it's even a little bit more than that. We require JDK 6 update 18 as an API level, or later, of course. That's like an early 2010 baseline. That's JDK 6 upgraded to include JXP 1.4 and Stacks 1.2, for example. In the IBM world, it happened at around the same time, so we need that API level from early 2010 as a minimum dependency. Of course, JDK 7 plays a central role here. That would be the mainstream JDK that Spring Framework 4 is expected to be used with initially. We also raised the baseline to Java E 6+ as a guideline, right? It's about individual specifications here, not about E6 as a platform level. We require JPA 2.0 now, for example. We also focus on Servlet 3.0, both of them being central parts of E6. However, Servlet 3.0, we technically only require for development environments. So if you want to use our mocks or that sort of stuff, our set of Servlet API mocks, then you'll have to be on Servlet 3.0 there. However, at deployment time, we are Servlet 2.5 compatible as long as you're not using actual Servlet 3.0 functionality, which fortunately is easy to identify. So as long as you're not using web application initialize or async processing, you're pretty much all set, even if your target environment is a Servlet 2.5 container. It's very explicitly designed to be that way, because we understand that there's plenty of existing runtime environments with Servlet 2.5 containers out there. On Java 6, possible to use JPA 2.0, but Servlet 2.5 based. And that's what we still want to be compatible with. We took the opportunity to remove all deprecated packages. Most of them have been deprecated for a long, long time, so it shouldn't come as a surprise. We removed many deprecated methods as well. Some of them remain in case anyone is checking. Some of them remain because we're pragmatic about it. We understand that there are pre-compiled third-party libraries out there talking to some methods that have been deprecated along the way. We preserve some of those methods if we know that there are commonly used pre-compiled libraries out there that cannot so easily change. We had to make a few compromises. In some cases, we upgrade other projects in our portfolio to be compatible with Spring Framework 4.0. But in most cases, you can use existing versions as you're used to. So even existing Spring Security versions, for example, would still work with Spring Framework 4.0. Don't have to be upgraded immediately. A central focus, of course, of the Spring Framework 4 generation is our Java 8 story. We raised the baseline to JDK 6+. We have JDK 7 as a mainstream level of the JDK. However, the most interesting part from the JDK perspective is certainly Java 8 and Spring Framework 4's ways of being a good citizen in the Java 8 world. It's about Java 8 language features. It's about Java 8 API features. And it's about runtime compatibility with JDK 8. So kind of independent in some way. With the language features, which is of course the probably most interesting part, we have Lambda expressions as just a really nice addition to the Java language. I expect this to be very commonly used in the near future. But it's really great for many use cases, and it's also a great fit for Spring's API style, as we're going to see in a few moments. Method references are kind of a variant of Lambda expressions. It's what Lambda expressions are being compiled to. For the purposes of this presentation, we're only going to focus on a few selected features in the Java 8 space here. If you'd like to learn more about it, we are already doing Java 8-oriented presentations. We will be doing a Java 8-oriented webinar in the near future where we're going to dive a little bit deeper. But for for today's purposes, let's just focus on the most important benefits to derive from this. So I'm going to show you the use of Lambda expressions. We're going to talk about JSR 310 dated time in a bit more detail. Quickly mention repeatable annotations, what we can do with Spring annotations to support that. And let me also mention here parameter name discovery. We've been talking about parameter names before. The ability for a framework to read parameter names for methods or constructors and in application classes. As of Java 8, this is actually a first-class feature. Java 8 comes with a dash parameters compiler flag that allows you, that instructs the Java 8 compiler to include a parameter name section in your class file. And this section basically comes with reflection API support, so we can use standard API to read the parameter names from such class files. You do need to specify that flag, so it's not happening by default, but it's a first-class feature. You don't have to switch to debug symbols. You can just say dash parameters, that's it. Of course, we also support the debug symbol variant still. You can also compile with dash debug or compile with both. It will work either way. But in any case, there's first-class support for this feature in Java 8, which is great because basically makes us feel better about relying on this in our programming model, in the cleanest version of our programming model. We didn't technically rely on it. There were ways to repeat yourself and avoid that need, as mentioned. But it's a great enabler where we don't have to use ASM, don't have to read class files anymore, where the JDK itself enables us to do this as a first-class feature. Right. So we're going to see a few examples in just a moment, but let me take the opportunity here to point out another perspective on JDK 8. It's about runtime compatibility of existing applications when deployed to JDK 8. Just imagine, not quite now, right? But imagine in half a year's time, in a year's time, JDK 8 is going to show up in deployment environments in some form. In some platforms as a service, some cloud platforms, in some data centers, in some hosting options. When deploying an existing application that's compiled for JDK 6 or 7 to such a JDK 8-based deployment platform, we're really not relying on much. There's no use of Java 8 language features, no use of 1.8 bytecode or anything like that. It's just about compatibility with reflection behavior, and just general standard implementations in the JDK libraries. This is not entirely trivial, but we did actually spend some time fine-tuning Spring as a framework to support that kind of scenario, even in the little dark corners. So taking an existing Spring-based application and deploying it to a JDK 8 platform, maybe because you want to benefit from virtual machine enhancements in JDK 8. There are actually quite a few, in particular towards memory management. That may be a good enough reason to deploy to JDK 8 for a start, without having to switch to Java 8 language features at all. So those kinds of scenarios are officially supported as well from our side, with Spring Framework 4.0 primarily, to some degree also with the latest Spring Framework 3.2 releases for existing applications running on JDK 8. All right, let's have a look at language features. Lambdas, which is the central language feature in Java 8, basically a kind of closure, but they're Lambda expressions. They are a sweet, short way to provide an implementation of a callback interface, fundamentally. The whole idea behind Lambda expressions are that the compiler, it's a compiler feature, so it's the compiler actually processing them. The compiler introspects where the Lambda expression is being applied and automatically coerces it into an implementation of a callback interface. So there has to be rules for those callback interfaces. They have to basically be single method interfaces, called functional interface in Java 8 terminology. Fortunately, in Spring APIs, you'll find many such callback interfaces. Consider Jdbc template, which has like connection, callback, prepared statement setter, row mapper, result set extractor. They are all natural natural functional interfaces. Java 8 Lambda expressions fundamentally, by convention, can be applied to those Spring APIs very, very naturally, actually without changing the Spring APIs themselves. Those Spring APIs, in many cases, date back to like 2004 and 2005. At the same time, even 10 years later, they are natural citizens for the Java 8 language conventions, which is really great to see from our side. So Spring as a framework has to do quite a few things to enable the use of Java 8 language features in general, the use of the 1.8 bytecode level and so forth. However, in terms of API design, it's just a natural fit. So it's about Jdbc template. JMS template has quite a few such callback interfaces. We even have a transaction template with a transaction callback interface. We have task executors, task schedulers with runnable and callable arguments passed in. Again, one method callback interfaces. So many, many of those to be found. Let's focus on Jdbc template because we're going to show this in an example in just a moment. A typical Jdbc template call, maybe let's just do it like this. A typical Jdbc template call looks like this. The only unusual part here is the use of Lambda expressions. But fundamentally, it's a regular, typical Jdbc template query call. The query method used here is the one that takes a string, the SQL string, a prepared statement setter, and a row mapper. We see two calls, basically identical calls with different source layouts. It's basically the same call repeated with different layout. The first line is the string argument for the SQL statement. The second one, the second argument after the comma, is the prepared statement setter argument. And that's the unusual part. We have a Lambda expression here, specified against an API that expects a prepared statement setter. And the third argument is basically matching against the row map argument in Spring. So we have a string passed in, a prepared statement setter passed in, a row mapper passed in. The prepared statement setter, let's switch back for a moment. Prepared statement setter has one callback method. The name is irrelevant. It's set values, but anyway, the prepared statement that comes in is important. So it's a callback interface that processes an incoming prepared statement. Can basically set any number of parameters on it. That's exactly what our Lambda expression does here. The PS part, before the arrow, the PS part refers to that prepared statement argument. You could also declare it with a type. You could say prepared statement PS, but you don't have to. You can shorten it to PS. And on the right-hand side, we have the more or less the method body in expression style. So it's not a full Java statement. It's in a kind of expression style Java statement where you perform a set string call, PS set string, a single statement on that incoming object, on that prepared statement. That's basically the prepared statement setter method body. So you're going to, mentally, you're probably going to have in your mind, I could pass in an anonymous inner class here. New prepared statement setter, I'm implementing the set values method, prepared statement comes in. Within the method body, I'm saying PS set string. And as a mental model, that works just fine. It's basically a kind of shortcut. Instead of implementing anonymous inner classes with plenty of like class and method signatures around the actually interesting code, we focus on the really interesting code here. We just specify the method body, that's it. We do the same for the row mapper in the next line, the rs row num line. Row mapper on our slide before has a results at rs int row num coming in. And it actually returns a mapped object. Map row returns a map object for each row in the result set. And that's exactly what our Lambda expression does here. Rs row num come in, two parameters here. We refer to them by name. So we could say results at rs int row num, but we don't have to. The names are sufficient. And on the right-hand side, we have a Lambda expression that says, okay, we basically build a new person object. We call our getString1 and our getInt2. That's maybe like name and age. We pass them into a person constructor accepting them, and we return them. So we don't see the return statement here, but there's an implicit return statement here because maprow expects an object to be returned, and this expression evaluates to an object. So that's basically the shortest possible version of a Jdbc template call with the use of two Lambda expressions. Personally, I find it particularly interesting to consider examples with multiple Lambda expressions. A single Lambda instead of an anonymous inner class is nice enough for a start, but the power of Lambda expressions really shows when you have calls that take several callback interfaces, as in our example here. Our second example in the lower half of the slide is the same basically as above, but with more traditional formatting. It's using a variant of Lambda expressions that points to a regular Java code block, more like a regular Java method body, you could think. So the PS, the prepared statement set one, has a regular Java code block with brackets, a PS set string call inside. It ends with a semicolon. There could be several such statements inside. It's a code block, right? A regular Java code block. It has to comply with standard Java code block rules. That's why the semicolon and so forth has to be there. The second Lambda, the RS row num number against the row mapper, is again in the second example, it's a regular Java code block. So it could have more than one statement inside, and since it's a regular Java code block, it has to have a return statement, as you can see here, and a semicolon at the end. So that's really what Lambda expressions can do to you and to your code. They are basically a way to provide an implementation of a callback interface. The compiler takes your Lambda expression, evaluates it against the target point that you're applying them to. So it knows what they go into, right? It sees a call against Jdbc templates query method, and it knows the signature of the target method. And then it coerces them into implementations of those callback interfaces. At runtime, Lambdas actually get compiled to method references to like synthetic private methods in the containing class. It's actually a very efficient way of representing them. It's even slightly more efficient than anonymous inner classes would be. But conceptually, it really helps to think about them as kind of a shortcut way to implement an anonymous inner class. Even if that's not exactly what happens at runtime, I find it conceptually useful. And if you look at the second example below, that really looks somewhat similar to anonymous inner classes. There's just no class signature and no method signature, but a regular method body. It's not so far from an anonymous inner class arrangement. However, it fits on this slide, right? We have two examples, each with two Lambda expressions on a single slide here. That really says it all. Try that with anonymous inner classes. There would be 4 anonymous inner classes on the slide. So that's Lambdas, and that's an almost complete definition of Lambdas. That's basically what Lambda expressions do. There's not much more to it. We almost explained, I think we even covered all variants, all regular variants of Lambdas. It's not a particularly complex feature. If you spend half an hour or an hour with them, play with them in an IDE, for example, in IntelliJ IDEA, with its great Java 8 support even at this point, you'll find them really, really useful and convenient and very natural. If you try them for an hour, they're going to feel very natural. The rules are straightforward, pretty simple. Even if you'd like to understand what happens at runtime, it's fundamentally a straightforward feature, a great addition to the Java language, since it's convention-based and can be used with existing APIs and libraries, as long as your runtime environment is generally capable of working with Java 8-based code. Because you can only use this with source 1.8 level, which implies target 1.8 level, which implies 1.8 bytecode format in your class files. So as long as your runtime frameworks are capable of understanding and working with the 1.8 bytecode level, this is available to you right now. Remember, JDK 8 is in release candidate mode as of this week. The recently released OpenJDK 8 build 124 is the release candidate build with the general availability date coming up in late March. So it's not far off. If you'd like to start a new development project right now, consider starting it on JDK 8 even at this very point. Spring Framework 4 is basically designed to support you right from this point in your development efforts. That's why we have such early support for Java 8. Maybe you're not going to deploy until late 2014 or even 2015, and you know it already, There's no reason not to consider JDK8 for such projects if you know that it's going to be available to you next year in production. All right, so much for a few Java 8 considerations. Quick tour through other JDK8-based features. This is JSR 3.10 date and time. It's basically a kind of successor to JODA-time, a fresh re-implementation of the same concepts that JODA-time had. It's not exactly identical. If you look into the details, it's in some cases it explicitly differs from JODA-time in some arrangement and some conventions. But initially, at least, they're quite similar. The central part of JSR 3.10 are the new value types: local date, local date time, and so forth. Basically expressive value types to be used in your domain model or in your value types, and replacing Java util date fundamentally, or Java util calendar. That was really the only standard way to represent them before. Now you have standard expressive value types. If it's just the date without the time, use local date. If it's a date and time specification, use local date time. If it's just a time within a day, use local time. If it's a date and time defined for a very specific time zone, use zoned date time. So for any such scenario, there's a corresponding value type. That's the correct representation of your value and your value's implications in your domain model. So it really goes right into the heart of what we're doing, building domain models, representing data types. From a Spring perspective, we support JSR 3.10 for our formatting and binding framework in particular, and for conversion to some degree. But the most important part is formatting and binding. Consider Spring's @datetime format annotation, which has been around since Spring 3.0. You could annotate a field and say, like, this is a parsing and rendering pattern for that value. It was primarily designed to be applied to like Java util date fields that otherwise wouldn't really say what they are, so that the pattern really was the only way to turn them into something proper and to know what you were parsing from. As of JSR 3.10 here, we still support a datetime format. You can apply a very specific custom parsing and rendering pattern as a kind of default convention for strings to be passed into this field, or for this field to be rendered out to some kind of text representation, be it HTML or JSON-based or whatever. As long as it's textual, a datetime format is a fit for it. However, a subtle but interesting detail is that the value types are now expressive enough for us to be able to more aggressively default here. Look at the local date field above, the birth date field. The @datetime format annotation is commented out because it's basically the default behavior. If you don't specify any datetime format here, Spring's binding and formatting framework looks at the value types and says, like, local date. It says it's the date. So we use the ISO date representation, not datetime, we just date, because local date said so. So we can more specifically default the conventions that we're using if no specific convention is given. With Java util date, that just wasn't possible. So this is really great stuff in JDK8. It's an API feature fundamentally, but it's an important API to agree on. The real benefit coming from JSR 3.10 here is going to show once all mainstream frameworks, be it like education frameworks, web frameworks, binding frameworks, persistence frameworks, once they all understand JSR 3.10 by default, the power is really going to show, the power of standard date and time value types. At the same time, we also support JODA-time, of course. We have been supporting JODA-time since Spring 3.0, and we still do in Spring 4.0. We require JODA-time 2.0 now, so we even, it's actually improved and extended JODA-time support that comes with Spring 4. So if you're on JDK 6 and 7 in particular, consider using JODA-time. It will look very similar to what you're seeing here, just using JODA-time imports. But the names of the value types are in many cases identical. And Spring accommodates for the API differences in many ways. You can use a datetime format, so you can have a very similar experience with JODA-time on JDK 6 and 7. But if you're on JDK 8, I mean, by all means, consider the standard Java time types. All right. Quick note on repeatable annotations. The above example is what you can do with Spring Framework 4 on Java 8 now. Add scheduled, repeating it with 2 different cron triggers on the same method that wasn't possible with JDK 6 and 7. As of JDK 8, for annotations that have been declared accordingly, the above works. The compiler will accept it just fine. We have to declare our applicable annotations in a repeatable form now, and that's what we do as of Spring Framework 4.0. So add scheduled and a few others in Spring. Basically, annotations that semantically can be repeated are declared to be repeatable now in a Java 8 compatible form. If you're on JDK 6 and 7, you can use the syntax below. So a containing add schedules annotation. For other annotations, there's always a different container annotation. That's the best you can do on JDK 6 and 7. Of course, also possible with Spring Framework 4.0. But if you're on JDK 8, by all means, benefit from the cleaner and more natural, more expressive, more readable version above. Right, so much for Java 8. I'm going to show you a few other important Spring Framework 4 container features. It's just a quick tour to give you an impression of what you can follow up on. There are many details to be discovered in our reference documentation, recent blog posts, and so forth. An important focus was on Groovy, still is on Groovy. And one of the outcomes here is this bean definition format. This is a DSL, a Groovy-based script that defines Spring beans. It's basically similar to Spring XML bean definitions, an external definition format saying like a bean of name and type with properties passed in. It even has support for XML namespace parsing. This format isn't new. It comes from Grails. It's called the bean builder in Grails. We call it Groovy-based bean definitions in Spring Framework 4. It's basically moving down from Grails to the core framework. And as of the next generation of Grails will also consume it from there. So there's a single place where this is then maintained. But it's then available, immediately available, to any kind of Spring-based application, any kind of Spring-based application architecture. The definition format itself is pretty powerful, has some really nice elements to it, since it's fundamentally a Groovy script. You can do anything that you can do in Groovy. You can import common classes above. You can use conditional statements below. So it's really nice and just way more dynamic and flexible than the rather rigid XML schema format is. But fundamentally, it's the same kind of configuration style expressed in a different language. At the same time, Groovy support actually, or our intentions with Groovy go much further. Just for a quick thought, right? Consider implementing an entire Spring-based application architecture using Groovy, no .java files, using Groovy all the way long. You implement Spring components, regular Spring components with Spring stereotype annotations, Spring configuration classes, everything that you're used to, everything that we've been showing in the state-of-the-art section before. You can do that with Groovy, since Groovy supports all of those Java language elements. It's actually really sweet to try to do it, like without any Java files involved. You can take that pretty far, and it's a usage model that we officially support. However, in practice, if you just like to selectively use Groovy, the bean definition format as shown here is a good starting point. Maybe implementing some classes, maybe just your MVC controllers using Groovy. There are many ways to integrate some use of Groovy into Spring-based applications. We also, aside from the bean definition format, we care for many subtle details here. So there's a lot of fine-tuning that we are doing or willing to do towards a natural support for Groovy. Groovy is a first-class citizen in the Spring Framework world. Right. Referring to what we've seen before as profiles, as a kind of simple kind of condition for selecting specific beans that are to be registered with a container, we have a completely refactored version of this in Spring Framework 4. It's now called a condition model, like literally, with a condition interface, condition context coming in, and then add conditional annotation. can basically say add conditional, and you implement a programmatic condition, a kind of callback that will be allowed to evaluate whether to register the annotated bean at runtime. There's rich context coming in. You can react to existing bean definitions, the presence of specific kinds of infrastructure, and so forth. So it's a very dynamic model. And profiles are now simply an implementation of such a condition. There's literally a profile condition, and Spring's add profile annotation is meta-annotated with add conditional profile condition. So this is, of course, an open model, an extensible model. You can define your own conditions. You can define your own deployment styles with that. You can take that pretty far in a custom way. But we're also, at the same time, exploiting it in one of our sister projects, that's Spring Boot in particular. So if you look at Spring Boot is really demonstrating the power of this condition model. It takes it as far as it can with really aggressive defaulting, where what you're specifying is very minimal. Check out the Spring Boot examples. For example, an MVC controller implemented in Groovy. You provide just the controller, nothing else, and you bootstrap it with an embedded web server with hardly any setup around. There's really smart and aggressive defaulting going on here, and it's based on the Spring Framework 4 condition model. So definitely check out Spring Boot. It's not the focus of this presentation, but it's a great follow-up. We provided the link to our new website there, the Spring Boot homepage on it. Definitely check it out. It went 1.0 RC1 this week. Spring Boot 1.0 RC1 is available. All right, let's return to the annotation model for just a moment. A subtle but important new feature in Spring Framework 4 is about the use of annotation attributes in the composable model. Of course, you could compose your custom scope annotation, your custom transaction annotation before. It was entirely possible in Spring 3. However, as of Spring 4, you can use attributes. You can declare attributes. This my session scope annotation above here declares a proxy mode attribute. Proxy mode, of course, refers to the proxy mode attribute in Spring's standard add scope annotation. There is a proxy mode to be set there. So just by convention, if it's the same name, a same named attribute, it refers to the same attribute in the meta annotation. So there's no additional setup necessary. You just declare an attribute of the same name here, and you allow users of your custom annotation to specify a proxy mode. So it's a nice design element. In particular, if you're designing like a set of annotations for an entire project team to use as a kind of guideline for the guidance effect of it all, then this feature can become really powerful. Not least of it all, because you can control not only the availability of attributes, but also the defaulting for such attributes. Look at the second example, my transactional below. This one has a read-only attribute. Read-only refers to the same named attribute in Spring's standard transactional annotation, as used as a meta annotation here. Read-only in Spring's standard annotation has a default of false. So if you're not specifying it, there are no read-only characteristics implied. The custom myTransaction annotation that we're seeing here has a read-only attribute without a default. According to Java annotation rules, this means that the value has to be specified. So every user of your myTransaction annotation, every time it's used, you need to specify read-only equals true or read-only equals false. This is actually an intentional feature here. You can use this for the guidance effect of it all, where you say like, I want users of that annotation to reason about the read-only status of their transaction. I want them to be explicit about it, to think about it, and to specify the correct flag value. Whereas if it's defaulted, they may forget about it. They're not seeing it, right? So here, by not declaring a default, you're forcing them to think about it and to specify. So that's overridable attributes and the use of defaulting with overridable attributes, a really nice addition to the composable annotation model in Spring. Let's revisit another part of our model, which is the matching between injection points and definition points. What we see above is our myBookAdmin service. In this version here, it takes a my repository generically declared for account. let's assume my repository is an interface and has a type variable for the entity type that it manages. This became pretty common over the years. So we're seeing that quite often lately. Our own Spring Data sister project has a repository model very much like that. So for such a model, there are typically multiple implementations of the repository interface in the system, registered at the same time. So if the injection point says, I want a my repository 4 account, what the container does is it goes through all matches by primary type, so all my repositories, and then it tries to find one where the full generic type declaration actually matches. So it says, like, among the my repositories, is there one that's specifically generically declared for account? If yes, that's our match, if only a single one is requested. And as you can see here, it's both the parameter above, the constructor parameter, declared for my repository account, and it's also an admin method, typically to be found in a different part of the system, right? Somewhere in a configuration class. That method is also declared for my repository bracket account in its return type here. For Spring to be able to resolve this, the information needs to be stored somewhere. So it needs to be in the method signature as shown below, or it needs to be in the extends or implement signature of an implementation class. So it's also sufficient for like a my account repository input class to say implements my repository bracket account in its declaration. So as long as that information, the specific generic information, is somewhere in the method signature of a factory method or in the implementation class hierarchy, we are able to find it and we're able to use it for matching purposes. Even if there are several my repositories, we always select the right one. That's a Spring Framework 4 feature. In Spring Framework 3, the generic type here would have been ignored. We would just have looked at my repository. We would have said there are several my repositories matching. It's not unique. You need to add additional metadata. So in Spring 3, you would have had to add a qualifier, like qualifier account, above at the constructor level and also at the admin level. With Spring Framework 4's capability of fully matching generic type structures, no such qualifiers are necessary as long as the type declaration itself is expressive enough. It's also more readable for a start. If you have qualifiers, string qualifiers next to it, it's really not as expressive and not as readable as this version here is. So again, it's also about readability of the source code and about not repeating yourself. All right, further container refinements. I'd just like to quickly point them out here. So they're all in our What's New section and in the reference documentation. But there's quite a bit more that we do in the container space. For example, you can declare an injection point with @lazy, which now means for this specific injection point, you want a lazy initialization proxy. You want a proxy implementing your declared type, lazily referring to a Spring target bean. That's basically what you could do before with the so-called provider interface, a provider of account repository with a get method. Every time you call in the get method, we actually grab an object from the container. So there was something like the possible before, but with @lazy, it's now a proxy. No get method to be called, a proxy implementing an interface typically, or a target class proxy, and every call to that proxy is being delegated to the actual target instance, only when the call comes in. So it's a bit like a scoped proxy, but it's primarily for resolving more complex dependency arrangements within a larger set of singleton beans, for example, where a component can explicitly say, I want a reference to that bean, but I don't need to use it immediately. So I'm saying @lazy, and I only want it to be there. I only require it to be there once I start invoking methods on it. That's what you're saying when you're saying @auto-write @lazy. So that's a nice variant of something that was possible before, but is now syntactically nicer and more expressive than older variants would have been. We can also, for injection points, accept arrays and lists. We always could do that, so that's an existing feature. But now we can inject that in pre-ordered form using Spring's ordered interface or @order annotation. if the target beans basically comply with those ordering rules, we pre-order them before injecting the array or list. Nice fine-tuning, right? You get it in pre-ordered form instead of having to sort them yourself. And a nice enabling feature as well, we were talking about proxies and target class proxies. For target class proxies, as of Spring 4, you can declare a target class proxy without having to provide a default constructor. Previously, you had to do that for target class proxies. For interface proxies, you were free to have any constructor arrangement. But for a target class proxy, where we're using the implementation class itself for the proxy instance as well, you had to have a default constructor just for that proxy, for the ability to use that class as a proxy class. That restriction has gone away now. We are using the OpGenesis library to create proxy instances, now target class proxy instances, without invoking any constructor, because that's fundamentally the correct thing to do. There is a target instance. That's the instance that contains the state. That's the instance where the constructor invocation is relevant. For the proxy, the class is just a template of method signatures, basically. It's semantically correct to not invoke a constructor there, so that's exactly what we're doing now. One of the effects is you can use any constructor arrangements on your target classes. So you can use constructor injection, whatever you prefer. No need for a default constructor anymore. In the composable annotation space, we extended the composability to the test context annotations. In the test context framework, there are several annotations, actually a few further ones, 3 of them listed here. They can also be used in a composable form now, building your own using Spring's annotations as meta annotations. And last but not least, in this little further refinement list, there's time zone management. So in Spring, there's existing infrastructure to manage a locale. The locale context resolver already existed in Spring MVC. There's a locale context holder at a lower level in the framework where different parts of the framework and different parts of your application can refer to a centrally managed locale per thread. Spring MVC would set that for every request. This existing infrastructure has been extended to cover time zones, partly for JSF310 support and Jodo time support. So those immediately consume such a managed time zone. So in addition to setting a specific locale for each request, you can also rely on setting a specific time zone if you provide the appropriate rules for it. So much for container refinements. At this point, I'd like to extend our coverage a little bit towards the middleware space. And a really important topic in Spring Framework 4 is WebSockets. Our WebSocket support comes in basically at 2 levels. There's native WebSocket support, raw WebSocket support, where you interact with the framework and with the communication model at the raw socket level. But the more interesting part from my perspective is that we support higher level messaging protocols on top. So at that point, this really turns into a message-oriented architecture. It turns into a messaging style. What we provide with Spring Framework 4.0 here, for that reason, is a combination of all those things. A low-level WebSocket infrastructure with a SockJS fallback option where you can use WebSocket style communication, even for scenarios where actual WebSocket communication isn't possible. For example, if browsers don't support it. There's a natural SockJS fallback option that can be easily configured. So we provide a foundational WebSocket support layer. We also provide a general messaging module with rules and annotations and types for general messaging endpoints. Support for simple messaging protocols goes with it, in particular for the common STOMP protocol. And we also support the combination. STOMP basically as a messaging layer on top of WebSocket communication channels. So this is really interesting stuff because it's an enabler for a completely different kind of application architecture. Very messaging oriented, completely different kind of communication style, even if you're building a web application. So the This is a work area in Spring where a lot of effort went into. There's great coverage from my colleague Rossen in terms of blog posts and a few recorded talks where he goes really deep into the design and practical usage considerations here. This very much is in line with Spring 4's mission to support concurrent processing architectures, messaging architectures, but also asynchronous processing of any kind. And in that line, we, for example, also provide an async REST template, where for any invocations, you actually get a future back, a listenable future back. You don't have to synchronously wait for the result to come in. So you can also design Jdbc interaction layers in an asynchronous style using that async REST template. But that's just an additional note. I'd like to show you just a quick example for how WebSockets feel like at a raw level. This is WebSockets at the handler level. A raw WebSocket handler. See the WebSocket handler interface. It's basically a WebSocket session and a raw WebSocket message coming in. It's basically unstructured, no specific protocol implied. What you can see above is a Spring configuration class. In this case, even a specific role. It configures WebSocket handlers. It registers a handler against the registry. And through a little with SockJS additional statement up there, it even allows SockJS fallbacks to be immediately available. That's all you need to do to enable SockJS fallbacks here. So that's basically working at the raw WebSocket level. From a messaging perspective, this is what you would typically do. A controller, an endpoint arrangement with methods and method level annotations that map incoming messages against specific methods. For example, the message mapping for trade below accepts a specific messages from an incoming destination, from a specific destination here. The incoming messages are mapped onto a trade payload object, pre-converted, passed into the method. Very similar to Spring MVC style controllers, in particular to Spring Web controllers that process REST style payloads. They really look very similar here. But instead of mapping to specific HTTP endpoints, we're mapping to specific message destinations here, or to specific kinds of events, such as subscribe events in the Stone protocol in the method above. The endpoint model is very similar stylistically to Spring MVC controllers. You can even combine it with Spring MVC controllers if you prefer so. So that's just a quick example to give you some idea of what Spring's message-oriented architecture model is about, with its specific support for Stomp and WebSockets, the SockJS fallback. It's a really comprehensive arrangement, even at this very point. All right, to wrap up, a few notes on further things. There's Java E7. We generally support the Java E7 level of specifications in Spring Framework for All, and the most important ones are listed here, the ones with relevance on Spring. The JMS 2.0 update isn't particularly exciting. It's basically the first JMS version to be released since 2002, when JMS 1.1 came out, so it's really, really overdue. But what's actually in there is more like the obvious, nothing particularly exciting. However, if you run against the JMS 2.0 provider, Spring's JMS support auto-detects it and supports a few additional JMS 2.0 features here, such as delivery delays, for example. With JTA 1.2, there's an annotation coming with it that can be used as an alternative to Spring's transaction annotation. If you prefer a standard annotation there, a JavaX annotation there, automatically detected by Spring, so no specific setup necessary to use that. Maybe the most common of these here is JPA 2.1. If you're upgrading to Hibernate 4.3, that's a JPA 2.1 provider. Spring Framework 4 comes with full out-of-the-box support for JPA 2.1 and also Hibernate 4.3. In particular, now in the current 4.0.1 release, that's what we fully support is the actual Hibernate 4.3 GA version and its little peculiarities. With Bean Validation 1.1, we also, it's a minor update really to the Bean validation spec, but we support Hibernate Validator 5.0 in particular as its reference implementation. If you consider upgrading to Hibernate Validator 5.0, Spring Framework 4 comes without full out-of-the-box support for it for the first time. And GSR 236, also worth a note here, it's a bit of a different kind of spec, but we support it in an interesting way. GSR 236 is a kind of extension of the Java Util concurrent executor service model. And what we do in Spring is get our standard executor service support, basically are the adapters that we already ship for Spring's task scheduler model and task executor model onto Java Util concurrent. If you set them up, they automatically detect whether they are interacting with a GSR 236 compliant extended executor service. And if they do so, they translate your incoming requests, your incoming calls, onto the best possible representation. So if they're on GSR 236, and what you specify coming in here is a cron trigger, we translate it onto a GSR 236 trigger. If that's not available, we have a different code path that takes a regular executor service and processes the trigger manually. So we try to interact with the target platform and the target thread pool in the best possible form. That's particularly interesting on a forward-looking note, where managed environments, both Java EE7 servers, but also cloud platforms and so forth, would expose GSR 236 compliant thread pools through an executor service model. And Spring Framework 4 automatically consumes them if pointed to it. It auto-detects them and uses them in the best possible way. And really an important enabler for asynchronous processing architectures when you're running in a managed environment. Right, down the same perspective, let's look at target service. Here's just a summary, which can also be found on our migrations page on GitHub, of recommended server versions. There's a bit of a change in our policy here. Technically, we have minimum system requirements, and you can deploy a Spring 4 application anywhere where those minimum requirements are met. However, from a support perspective, from a reproduction perspective, if you submit an issue to us, we request to be at least at a reasonably recent maintenance level of each of these servers. So if you're deploying to Tomcat 6.0, that's the server 2.5 server, that's fine. But please at least use a reasonably recent maintenance version of Tomcat there, as listed here. The same applies to like JD and so forth. We also support WebSphere 7, for example. As long as you're on 7.0.09 with the JPA 2.0 feature pack, you're fully covered. Spring Framework 4 applications deploy just fine. That's an important deployment target for Spring. And of course, WebSphere 8 and 8.5 work just fine as well. On WebLogic, at least if you're at least on 10.3.4 with the JPA 2.0 feature installed, then Spring 4 applications deploy just fine, even if they're using JPA. This page also lists where WebSockets are being supported. And on a particularly interesting note, WebSocket support, standard JSR 356 compliant WebSocket support, has been backported to Tomcat 7.0.47 and higher. You don't need to upgrade to Tomcat 8 to have WebSockets. Tomcat 7.0.47 and higher is sufficient. We support it on Tomcat 8 as well, of course, on JD 9.0 and JD 9.1. As of Spring Framework 4.0.1, we also support Wildfly, WebSockets on Wildfly, which is the next generation of the JBoss application server. On a related note, for third-party libraries such as Hibernate, Jdcache, Quartz, and so forth, we have a policy now where we're supporting a 3-year range back from any given Spring Framework version. The then current versions of each library we would still support. So at this point, that means concretely that we support Hibernate 3.6 and higher still, Jdcache 1 and higher, Quartz 1.8 and higher. But this is going to raise quite soon to Jdcache 2.5 and higher, Quartz 2.0 and higher, Jackson 2.0 and higher, for example. Hibernate 3.6 support we will probably preserve for a longer time since it's so common out there. So it's a bit of a policy change where we don't support third-party libraries way back into history. We support them 3 years back in history, basically, as a simple guidance rule. These specific versions can be checked on our migrations page in the documentation. So we're already in upgrade considerations, basically. Here's the link in the middle. Here's the link to that migration page on GitHub if you'd like to check out some details. Generally speaking, we strongly recommend an upgrade to Spring Framework 4. If you're considering the use of Java 8 language features, this is basically mandatory. If you're on JDK 6 and 7, it's strongly recommended. Spring Framework 3.2 is in maintenance mode already. So it's going to see a 3.7 release on Monday, so it's actively maintained. It's kept at a very recent level, supports many recent little things still. But fundamentally, it's in maintenance mode. New features are going to be seen in the 4.x line only. We have the 4.0.1 release coming up on Monday. We have a 4.0.2 release scheduled right after OpenJDK 8 GA in late March. So that's where basically little features can come in, will come in some form still. A 3.2x line turns into basically strict maintenance mode from 3.7 onwards. On a forward-looking note, and to conclude this tour, let me just quickly talk about our Spring Framework 4.1 plan. The most interesting part is we have a shorter iteration plan. So 4.1 is actually already on the horizon. We intend to have a release candidate ready in June, and we intend to be generally available with it in August. So it's an 8-month iteration from Spring Framework 4.0. There's quite a few themes planned for it. Web resource handling may be one of the most important ones, where we had many requests from many sites for refined features in the HTTP cache control, for resource pipelining. There are many related little features that add up to hopefully truly comprehensive web resource handling that we're working on towards the 4.1 target here. We intend to revisit our caching support, since the JCache 1.0 specification is about to go final. It's in final draft and it's all went through, but they just didn't release it yet. So we're going to align with it, likely going to support its set of annotations, going to extend our JCache SPI support, which we already have. And we are also going to add a few user-requested enhancements to Spring's own caching model. A JMS overhaul is really due. We intend to align it with our messaging module, allowing you to use the endpoint style that we've seen, that's been defined by our messaging module, the simple endpoint style for simple messaging purposes, to bind it to JMS brokers. So that's a key working area for Spring Framework 4.1. And we generally have a focus on performance improvements. The idea here is that we are going to work on specific areas of improvement, such as, for example, the use of spell expressions. Compiling spell expressions on the fly at runtime down to bytecode is an interesting experiment for heavy use of spell expressions. And to improve startup performance where we can, in particular towards starting up more expensive third-party middleware. So there are quite a few work areas where we are comfortable with to deliver the release candidate in June here. The chances are that the next iteration is also going to be about 8 months. So that would be Spring Framework 4.2 in like April 2015. All right, so much for this tour. Thanks for all your attention. Here are a few further pointers. As I mentioned, check out Spring Boot. There's our new Spring.io website with a brand new Spring Framework homepage, actually. Some nice information how to grab the latest snapshot. So if you're up for it, give the latest Spring Framework 4.0.1 snapshot a try. It's basically a release candidate snapshot for what's going to become publicly available on Monday. So feel free to give it a try. Our website contains the mailing coordinates for it. And there are quite a few channels where we publish presentations and webinars like this one. So there's a lot to follow up on. Thanks for staying on the line for so long. It's been a long presentation. There's maybe a question or two that we can pick up on the audio channel still.
Yes.
So let me have a quick look.
Yeah, I think there's just one that I thought might be good for you to comment on. I think all the others have been answered. Because it might do some justice to those people that are having the Spring versus or Spring and Java EE debate. It's about CDI.
Right, I've just seen the question. Yeah, the question is, can I use CDI, context and dependency injection, in my applications? I suppose there's a question in Spring-oriented applications. Fundamentally, CDI defines its own kind of framework. It's very much a kind of component framework for the EE platform in many ways. So it's a kind of complete component framework in its own right. That's what it's aiming to be. If you have some CDI usage in some applications, I mean, all the power to you, right? Whatever works to solve the problem. It integrates nicely with Spring. There are a couple of bridges available, or if they're separate systems that have like REST endpoints to communicate, then it wouldn't even be necessary to do actual component integration. Right? There are many ways to combine those technologies, but fundamentally, the Spring programming and configuration model is a completed comprehensive model in its own right. We selectively integrate standard annotations, as you've seen, JSR 330 for dependency injection, JSR 303 for bean validation, the JTA 1.2 transactional annotation. There are many standardized annotations being integrated into Spring's programming and configuration model. So if you look at like a typical CDI component as a typical Spring component, they're going to look somewhat similar. But the closer you look, the more differences you're going to find. In Spring components, almost always have a stereotype, and they are being detected by stereotype. In CDI, components usually don't have a stereotype. They are being detected by presence in a jar file. So it starts with the bootstrapping rules, and it only goes from there. There are many differences in the details, semantic differences, stylistic differences, conceptual differences. So from that perspective, if you're familiar with CDI, I'm sure you'll find yourself familiar in the Spring programming model initially. But keep in mind, Spring has many ways of its own for good reasons. And to use Spring basically in its most comprehensive and convincing form, I would strongly recommend to use it according to typical Spring recommendations. That's where the power shows through. That's where the readability effect to your source code really shows through. So we're really trying as hard as we can, for that to be comprehensive and just clean in its own right. So that's if the question is basically about how do you get the best possible experience using Spring, that's what I would recommend, Spring's programming and configuration model as the primary perspective.
Juergen, thanks so much for that. I think that's pretty much it. We've answered all the other questions in the chat, so and we're almost at an hour and a half here. So thank you for your heroic 4 repetitions of this webinar. And
you're welcome.
Very much, yes. Thank you. I just want to invite everyone on the phone. That there's actually still quite a number of people on the line. Looks like there's still 100 plus folks. We are having a great webinar next month, February 11th. Stuart Williams, an Apache Tomcat committer, is going to be joined by Daniel Mikusa, and they're going to be talking about doing an introduction to Apache Tomcat 8, and that's on February 11th. Registration for that is open, so if you'd like to join the event, just go to spring.io/blog, and you'll see the posting there. Also, next month we're going to be having none other than Spring Data project lead Oliver Gierke and Thomas Derima. They're going to be talking about Spring Data repositories and some best practices around those, how to hook them, how to use things like Query DSL, et cetera, et cetera. So that is going to be on February 18th. So we would love to invite you to those webinars and hope to see you there. Today's recording will get posted to spring.io/video, which is just a redirect to YouTube, and we'll post a notice in our Atom feed on the Spring.io blog. The recording of this webinar should be posted today, so keep an eye out for that. And then just as a quick note, we have not enabled direct HTTP downloads for Spring binaries from the Spring.io website currently. So if you're one of the few that really needs an HTTP download for some reason, there is a artifact. You can get them from the Artifactory server. We just have that question occasionally, so I thought I'd bring it up. And there's a Spring repository fact that can really kind of walk you through what's going on. But in general, we really look forward to hearing your feedback on Spring Framework 4.0 and some of the other things that Juergen's touched on today. So please hit us up on Twitter at Spring Central or elsewhere on social media, etc., and let us know what you think. We'd love to hear your feedback. Thanks, everyone. And Juergen, if you have any closing comments, let's do that and then say goodbye.
Just thanks, everyone, for your attention, and have a great experience trying Spring Framework 4.1. For the 0.1 once it comes out on Monday. And if there are any issues in your migrations, let us know on Jira. We're really there to help you. Thanks.
Bye, everyone.